Net change and total change, section 5.4. If v of t for t between A and B represents the velocity of a particle from time A to time B, then the integral from A to B of v of t dt represents the displacement or net change in position from time A to time B. And the integral from A to B of the absolute value of v of t represents the total distance traveled from time A to time B. More generally, if f prime of x represents the rate of change from x equal a to x equal b, then the integral from a to b of f prime of x dx represents the net change from x equal a to x equal b, and the integral of the absolute value of f prime of x represents the total change from x equal a to x equal b. So I think this will be clear with some examples. Here's an example. V of t, the velocity v of t is t squared minus 2t minus 8. Represents the velocity in feet per second of a particle at time t seconds. Find the net change in position from time 0 to time 4 seconds. So the net change is going to be the integral from 0 to 4 of v of t dt. So that's going to be the integral 0 to 4 of t squared minus 2t minus 8 dt. You take the antiderivative, it's t cubed over 3 minus t squared minus 8t, evaluated at 0 and 4. And this will be put in 4 there. 4 cubed is 64 over 3 minus 16 minus 32. At the lower limit everything is 0. So this is 64 over 3 minus 48. We can get a common denominator. 64 over 3 minus 144 over 3, which would be negative 80 over 3. So it would be the net displacement would be negative 80 over 3 in the backward direction, whatever direction that is, in the reverse direction. Okay, part B, the net change from 4 to 5 seconds. The integral from 4 to 5 b of t dt. Integral from 4 to 5 of t squared minus 2t minus 8 dt. And we take the antiderivative, it's t cubed over 3 minus t squared minus 8t. Evaluate it 4 and 5. If we put in 5, we get 125 over 3 minus 25 minus 40. And if you put in 4, you get minus 64 over 3 minus 16 minus 32. So that's going to equal 125 over 3 minus 65. If we distribute the minus sign, this will be minus 64 over 3 plus 48. And this is equal to 125 minus 64, 61. 61 over 3 minus 65 plus 48 is negative 17. So it's 61 over 3 minus 51 over 3. And that's going to equal to 10 over 3. this is feet. These measures are in feet. Okay, so that's the from 4 to 5. It's the net displacement is 10 over 3 in the positive direction. Okay, so let's part C, 0 to 5 seconds. We could just add these two here. So part C. Keep that up here. We just add the answers from part A and part B. I'll do it on a separate page. The integral from 0 to 5 v of t dt. We already computed integral from 0 to 4 and the integral from 4 to 5, so we can just add the results there. This is negative 80 over 3 plus 10 over 3, which would be negative 70 over 3. That's the net displacement from time 0 to time 5. Part D, the total displacement. Total displacement would be the integral of the absolute value of v of t dt. So the integral from 0 to 5, absolute value of t squared minus 2t minus 8 dt. And we can factor this 0 to 5, absolute value. T times t gives us t squared. We need two numbers to multiply to negative 8 and add up to negative 2, so negative 4 and plus 2 should do it. Okay, so this so let's look at the sign here. Negative 2 it's 0. At 4 the velocity is 0. And we want to go from 0 to 5 seconds. So there's going to be a change, possible change of sign there. At 0 seconds, we have positive times negative, which is negative, and at 5 seconds, both of these are positive. So this is going to be, if we want the absolute value of the velocity, we have to take the opposite sign between 0 and 4. So this is going to equal to integral from 0 to 4 of the minus t squared plus 2t plus 8, and then so we're taking that with the opposite sign, so we get something positive, and then from 0 to 4 to 5 with the original sign. And this is just going to be equal to minus the integral 0 to 4 of t squared minus 2t minus 8. We factor out the minus sign, and we already computed this. Okay, so this we already computed. This was negative 80 over 3, so it's going to be minus negative 80 over 3. And this one we already computed too. It was 10 over 3. So we have double negative is positive, so we have 80 over 3 plus 10 over 3, which is 90 over 3, or 30 feet. Okay. So the total displacement. So it goes backward for 80 over 3 feet, and then it goes. So the direction it goes backward 80 over 3 feet, and then it goes forward 10 over 3 feet. So the net displacement was negative 70 over 3, but the total distance traveled is going to be 90 over 3, or which is 30 feet. Okay. Okay. So let's so that gives you an idea of the net distance traveled versus the total distance traveled. So, I mean, another example would be if you let's say you take the train to school. Say you take the train to CCP, and then you have your class, and then you go back, take another train going back. Let's say you live 3 miles away. So you travel 3 miles to CCP. You travel 3 miles back. Total distance traveled is 6 miles, but the net distance traveled. You started at home and you ended up at home, so the net distance traveled is 0. So now that's sort of the difference between total distance and net distance. Here's another example. V of t equal 48 minus 32t is the velocity in feet per second of rocket at time t seconds after fuel runs out. Find the net change in position from 0 to 1.5 seconds, 1.5 to 4 seconds, 0 to 4 seconds, and the total distance traveled from time 0 to 4 seconds. Okay, so part A, we want the integral from 0 to 1.5 of 48 minus 32t dt. So this is, take the antiderivative, that's going to be 48t minus 16t squared from 0 to 1.5. I think I'll make this into 1.5 is the same as 3 over 2. Sometimes it's easier to compute with a fraction than a decimal. Okay, so this is going to be 48 times 3 halves minus 16 times 3 halves squared. And at the lower limit, we just have 0. You plug in 0 for t, you get minus 0 there. So 48 goes 24. 24 times 3 is 72. This is going to be 16 times 9 fourths. 4 into 16 goes 4. 4 times 9 is 36. So this is 72 minus 36. It would be 36 feet. It's traveling upward 36 feet from the time that the fuel runs out. Okay, and part B, we want the net change from 1.5 to 4. So the integral from let's say 3 halves to 4 of 48 minus 32t dt. That's 48t minus 16t squared. Evaluate at 3 halves and 4. If we put in 4, 4 times 48 I think is 192. It's 4 times 40 is 160. 4 times 8 is 32. 192 minus 4 squared is 16. 16 on 16 is 256. And at the lower limit, let's see, we'll have 48 times 3 halves minus 16. 3 halves squared is 9 fourths. And let's see, if we subtract here, this is going to be minus 64 minus 72 minus 36, minus 64, minus 36, it'd be minus 100 feet. So the net change from, so it's a negative because it's going down. Part A was a positive 36 feet, it's going up 36 feet, and this is a negative 100 feet, it's going down 100 feet. Okay, so part C, from 0 to 4, the net change from 0 to 4, so we just want to add the results from part A and part B. So part C, integral from 0 to 4, v of t dt is integral from 0 to 3 halves v of t dt plus integral from 3 halves to 4 v of t dt, and this is going to be this is our answer to part A. This is going to be 36 plus our answer to part B, which is negative 100, and that'll be negative 64 feet. So the net change from time 0 to 4 is a downward 64 feet in the downward direction. Part D, the total distance traveled. So the opposite goes up and it goes down. So the total distance traveled is going to be more than the sort of the net distance traveled. So this is 2D. So the total distance traveled is going to be the integral from 0 to 4 of the absolute value of v of t dt. The integral from 0 to 4 of the absolute value of 48 minus 32t dt. And this is going to be okay, so if t is 3 halves, this is going to be 0. If t is less than 3 halves, for example, if t is 1, for example, this will be positive. If t is more than 3 halves, for example, if t is 2, this will be negative. So so the absolute value is going to be the same sign between 0 and 3 halves, but it will be the opposite sign between 3 halves and 4. So this is going to be the integral from 0 to 3 halves v of t dt, and then we want the opposite sign from 3 halves to 4, so minus the integral of from 3 halves to 4 v of t dt. So this is going to be so this is our answer to part A was 36, and then our answer to part B was negative 100, so this is minus negative 100. So 36 plus 100 is 136 feet. So the total distance traveled is 136. The net distance was negative 64, but it goes up and then it goes down, so it's sort of backtracking. Part E, the rocket hits the ground after 4 seconds. I'm going to find a formula for the height of the rocket. The height, h of t, is going to be the antiderivative of the velocity. It will be one of the antiderivatives of the velocity, but we want to find out which one. Antiderivative of 48 minus 32t dt, and this is going to be 48t minus 16t squared plus a constant. And we have to figure out what the constant is. So we're given that the rocket hits the ground after 4 seconds. So we know that h of 4 has to be 0. So h of 4 is 48 times 4 minus 16 times 4 squared plus a constant, and that has to equal 0 because the rocket hits the ground. The height at 4 seconds is 0. So this is 192 minus 256 plus a constant equals 0. So this is, if you subtract here, you get minus 64 plus the constant equals 0, and then add 64 to both sides. You get the constant is equal to 64. So that means h of t is, let's put these in order from largest exponent. So minus 16t squared plus 48t plus 64. Okay. And, okay. Okay, so, okay, another example. Well, the first two examples involve velocity. This one is does not involve velocity. Prime of x is 4 minus 0.2x, represents the marginal profit in producing a gallon of paint. Find the net change from 0 gallons to 20 gallons. Net change in profit. So that'll be the integral from 0 to 20 of p prime of x dx, and that's the integral from 0 to 20 of 4 minus 0.2x dx. Take the antiderivative, it's 4x x minus 0.1x squared from 0 to 20. And if we put in 20, it's 4 times 20 minus 0.1 times 20 squared. At the lower limit, we just have 0. So this will be 80. 20 squared is 400, and then times 0.1 would be 40. 80 minus 40 would be $40. The net change in profit is $40, going from 0 to 20. Okay, so from 20 to 30, we want integral from 20 to 30, p prime of x dx. Integral from 20 to 30 of 4 minus 0.2x dx. This is going to be 4x minus 0.1 x squared from 20 to 30. If we put in 30, it's 4 times, I'll do it on the next line. 4 times 30 is 120. 30 squared is 900, and then times 0.1 is 90. At the lower limit, we're going to have 4 times 20 is 80. 20 squared is 400, and then times 0.1 is 40. So this will be negative 30 minus 40 would be negative 70. So the profit goes down between 20 and 30. Okay, okay, part C. The net change from 0 to 30. We would just add these answer results from part A and part B. So part C is going to be 40 plus a negative 70 would be a negative $30 from 0 to and then the total change, part D is the total change from 0 to 30. So that so it goes up and it goes down. So you want to go the amount that goes up plus the amount that goes down. Get another piece of paper here. Okay, so part D, so 3D. The total change in profit is the integral from 0 to 30 of the absolute value of p prime of x dx. And so it's integral from 0 to 30 of the absolute value of 4 minus 0.2 x dx. And this is okay. So this will change sign when x is see, x is 20. Yeah, it should change sign when x is 20. So if you put in 20 there, 0.2 times 20 is 0.4, is 4. 2 times 20 is 40, but you have to move the decimal point over, so it would be 4. 4 minus 4 is 0. So if you, we want the time go from 0 to 30. So at 0, the 4 minus 0.2x is going to be positive. So this is going to be positive here. And at 30, 0.2 times 30 is 6. So that's going to be 4 minus 6 is negative. So it's going to be negative here. So between 20 and 30, we want the opposite sign. So this is going to be integral from 0 to 20 with the original sign. And then we want the opposite sign from 20 to 30. So we can use our answers from part A. So part A, this was 40, and this integral here was negative 70, but we're taking the opposite sign. So it's be 40 plus 70, which would be $110. So it goes up 40, it goes down 70, it goes down yeah, it goes down 70. So the net change is negative 30, but the total change is 110. Okay, so part E. If the profit for 10 gallons is 0 for 10 gallons of paint, find a formula. So, so you want the, P of x is going to be an antiderivative of P prime of x dx, so it's an antiderivative of 4 minus 0.2x dx, and this is this will be 4x minus 0.1x squared plus a constant. And so P profit at when x is 10 is 0. So P of 10 is going to be 4 times 10 plus 0.1 times 10 squared plus a constant, and they said that's equal to 0. So we just need to solve for the constant. So 4 times 10 is 40. 10 squared is 100. 100 times 0.1 is 10. This should be a minus. That's a minus there. So this is 40 minus 10 plus a constant equals 0. 40 minus 10 is 30. And then subtract 30 from both sides. You get the constant is equal to negative 30. So that means that P of x is, if we write these in order from the largest power of x, it will be minus 0.1 x squared plus 4x minus 30. So negative 30 would represent the overhead cost. You know, if you have sell 0 gallons of paint, you're out $30. You have 0 plus 0 minus 30, so you're out $30. So that's the overhead cost. It would be maybe the rent or the utilities, and something that you have to pay regardless of whether you sell any paint or not. 4 is the marginal cost on each gallon of paint. This x squared term would represent a loss of efficiency if you trying to produce more paint than your factory can handle, or maybe you have to pay overtime. Okay, so that's that problem. Okay, number 4. P of t is 100 plus 20 times sine of 2 pi t represents the blood pressure in milligrams mercury after t seconds. Derivative p prime of t, well, the derivative of constant is 0. Derivative of sine is the cosine, so there's going to be 20 times the cosine of 2 pi t, and then you have to multiply, use the chain rule. Derivative of 2 pi t is going to be 2 pi, so this times 2 pi, so this would be 40 pi cosine of 2 pi t. So that would be represent the rate of change in blood pressure. So it says interpret p prime of t, that would be the rate at which the blood pressure is changing. Find the net change in pressure from time 0.25 seconds to 0.75 seconds. So that would be, we could use the original function, or we could use the derivative. It's going to be p of 0.75 minus p of 0.25. I think I prefer fractions here. It's p of 3/4 minus p of 1/4. So that's going to be p of 3/4 is 100 plus 20 sine of 2 pi 3/4 minus 100 minus 20 sine 2 pi times 1/4. So the 100 minus the 100 will cancel. And we'll get so 4 into 2 into 4 goes 2, so it's 20 sine 3 pi over 2 minus 20 sine pi over 2. 2 into 4 goes 2, so this is it'll be pi over 2. So sine of 3 pi over 2 is going to be negative 1. So this will be a negative 20. Sine of pi over 2 is a positive 1, so there's minus 20 be minus 40 milligrams of mercury. Would be the net change. Net change from 0.75 seconds to 1 second. I get another piece of paper here. Okay, so this is 4C. So this is going to be force is going to be P of 3/4 of P of 1 rather. We're going to P of 1. P of 1 minus P of 3/4. Okay, so this is going to be P of 1 is 100 plus 20 sine of 2 pi minus P of 3/4, which would be 100 minus 20 sine of 3 pi over 2. So sine of 2 pi is 0, so 100 minus 100 will cancel. Those cancel. Sine of 0 is, sine of 2 pi is 0, so this is 0. This one, sine of 3 pi over 2 is negative 1. So this is minus 20 times negative 1. That'll be 20 mmHg. So the net change is in the increase in pressure of 20 milligrams of mercury. Total change from okay, so net change from 0.25 to 1 second. So it's P of 1 minus P of 1/4. And so it's going to be 100 plus 20 sine 2 pi minus 100 minus 20 sine of pi over 2. 100 minus 100 cancels. And sine of 2 pi is 0. Sine of pi over 2 is 1, so this would be minus 20. It would be minus 20 mmHg. Part E, the total change. From 1/4 to 1 second. Okay, so the P prime of t is we said was 40 pi cosine of 2 pi t. So so this will be you'll have a cosine of if you put in 1/4 there, this is cosine pi over 2 to and you put in 1 there to cosine of 2 pi. So cosine of 2 pi, so when t is 1, cosine of 2 pi is 0. And let's see, let's put in t, when t is 0, oh, no, I'm sorry, cosine of 2 pi is 1. And at time 0, cosine of 2 pi is 1. And Okay, so we had 1/4, 1/2, 3/4. Okay, so if t is 1/4, you have cosine pi over 2, which is 0. T is 1/2, you have cosine of pi, which is -1. And at 3/4, you have cosine 3 pi over 2, which is 0. So so 1/4 it's going to be negative between 1/4 and 3/4, and positive between 3/4 and 1. So you want to take the so this is going to be integral from so we want to take the absolute value of the derivative from 1/4 to 3/4. So the absolute value of p prime of t from 1/4 to 3/4. I mean, you want to take the opposite sign rather. You want to take minus. You want to take the minus opposite sign from 1/4 to 3/4, and then the positive sign from 3/4 to 1. Okay, so 3/4 to 1, we had an answer of from 3/4 to 1. That was part C. We had an answer of 20, and 1/4 to 3/4. That was part B. We had an answer of -40. So it's going to be minus -40 plus 20, be 40 plus 20, be 60 mmHg. So that's that would be the total change from in the blood pressure from between 1/4 of a second and 1 second. And that concludes this presentation.